All right, what's up, guys? This is lesson 3. We're still talking about triangle proofs. And if you remember, last time we learned 2 shortcuts for proving that triangles were the same. And they were side, 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 and side, angle, side postulates. Today, we're learning about 2 more shortcuts. Yay, who doesn't love a good shortcut? Now, they are angle and side, like phrases again, but remember the order does matter. So these are going to sound similar, but the order does matter. The first one's called angle, side, angle postulate. So it's ASA. The second one is angle, angle, side, and this one's a theorem, so you can prove it. We're not going to. We got enough proofs going on here. But this one's AAS. And of course, I'll abbreviate them. They look the same. It looks like, oh, 2 pairs of congruent angles and 1 pair of congruent sides, but the order makes all the difference here. So let me draw pictures here and write in what the sentence says for each one. Angle, side, angle postulate says that if 2 angles and the included side, we saw that word included last lesson, but if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, that's enough information being the same to stop your proof and say the triangles are congruent. So let's just draw a picture. I feel like the visual always helps. So here's 2 triangles, and you know that 2 angles are congruent. So it doesn't matter which ones we mark. Let's say those 2 are the same, and those 2 are the same. If the side that's included between them, or basically it's going to be the side between those 2 angle marks. So come over here, it's this guy right here. If between your angles, that side right there, if that side is marked congruent, this is an example of angle, side, angle. That information in that order, that's enough to say your triangles are congruent. Now, angle, angle, side is a little bit different. This one says if 2 angles and a non-included. Some of you have a headache already, I'm sure. But if 2 angles and a non-included side are congruent to 2 angles and a non-included side of another triangle, triangles are the same. Let's picture it up. Okay, 2 angles again. Let's do 2 different ones. Let's do maybe the top and then this guy over here. So this time it's the non-included side. It's not the side that's between your angles that are congruent. So it's not this one. It's one of the other 2. Doesn't matter which one. Maybe we'll just mark that pair. If it's not the side between the 2 angles marked, this is angle, angle, side. And I just kind of look at the information. It's kind of strung all together right here. Going around it this way would be there's too much empty space. That's kind of how I see it. Who knows if that'll help you. But I kind of go around it here. It's angle, angle, side. Or side, angle, angle. SAA, that's the same thing backwards. So either way, that's cool. It can be hard to tell the difference here. So that's going to be a big part of this lesson, just practicing which one's angle, angle, side, which one's angle, side, angle. So let's do this with our example at the bottom here. So they say, is there enough information to prove that the 2 triangles are congruent or not? So, and when they say that, and they're even telling you, if so, name the shortcut. So total, we have 4 now. So we could use any of the 4 to justify why these are the same. So think all of our shortcuts from here on out. So let's look at the first one. I don't see anything that I could mark on my own. And guys, you can always mark these 2 things yourself. Vertical angles and the reflexive property. You can always mark those yourself. For example, on this third one, I see vertical angles right here. I would mark that myself. Beyond those 2 things, you just have to go off of what's marked on the picture here. So let me look at just one triangle. Look at one triangle on its own. And I see that it's 2 angles and it's the side between. So this is angle, side, angle. Make sure it's the same over here. Yep, it's two angles, and it's the side between those two. So this one's good. And the shortcut is angle, side, angle. The second one, these are not vertical angles. It's not an X right there. I can see how you would confuse it with that. So I just have to look at one triangle on its own. That's what helps me. And I see SSA or ASS. Same thing over here. ASS is the order. It's not the angle between these two sides. So it's not side, angle, side. This one is ASS. And yes, I just wrote profanity on my notes. This one would be way too much fun if it was a shortcut. It doesn't work. Sorry. Okay, this one, we marked the vertical angle, so I can look at that. I look at one triangle on its own. I see two angles marked the same and a side. So it's one of these two new ones. It is not the side between the angles. So this is angle, angle, side. Okay, I want you guys to see if you can do this last one. Let's jump right into the proofs. We have 3 of them today. I'm going to do all of them, maybe ask you some questions along the way. All of the proofs, though, we're trying to use one of our shortcuts. So again, let me remind myself. And the lesson, guys, is over these 2 shortcuts. But if one of the other 2 worked, then that's fine. Use it, because the goal is to try to prove the triangles are the same. So whatever shortcut you can use, go for it. Now, you always start your proof with the given. So I just copy it in there. You always end with what you're trying to prove. So maybe let's just get the outline going. But I'm not even going to think. I'm going to say, okay, I know what I'm given. Angle QRT, STR. I'm actually given 2 things here. So I'm going to list them as 2 different statements. Both were given. That literally required no skill, no thought. I just took these 2 congruent statements and I broke them up and said given. And I should probably say 2 right there. That's better. You always want to end with what you're trying to prove. So whether you have any idea what you're doing or not on these guys, and I get it, sometimes these are just like a nightmare for people, but you're always trying to prove that this triangle is congruent to this one. So you know that's going to be your last statement here. Now, all 4 of these shortcuts require 3 congruent parts. So far, I have 2. I have an angle pair. I have another angle pair. I'm just after that 3rd thing, and once I have it, I can decide which shortcut it is that I'm talking about. Now, my suggestion, if they do not mark what's given on the picture, or anytime you know something's congruent, mark it on the picture, because that's going to help you see the order a lot easier. They already marked those angles, which was nice. So I just have to step back and say, okay, where's the 3rd congruent part here? And again, you can always mark vertical angles and the reflexive property yourself. I see that the 2 triangles here, they share that side RT. So I know that RT is congruent to RT, and that's the reflexive property. So there it is. There is my 3rd congruent part. And I only like made that list off to the side, guys, just to show me like, okay, I got 1, 2, 3. This is not necessarily the order that I'm going to justify why my triangles are the same. I have to figure out which shortcut it is. I do have 2 congruent angles in one side though, so it's going to be one of these 2. This is where I look to the picture to tell me that, not this. Don't let me confuse you. I look at one of the triangles and I look at all the marks. I see that there's 2 angles in one side. It is not the side between the 2 angles though. So it's not ASA, it's angle, angle, side. That shortcut justifies why your triangles are congruent. Okay, proof 1, done. That was like level 2 or 3. That was pretty straightforward. They gave you everything but the reflexive property. I feel like this one might be a 5. Here we go. Okay, I'm just going to copy the given all in one statement. Doesn't matter whether you break it up or not. I'm kind of giving a lot of random information here. Okay, so I just like recopied the given, statement 1. Now, nothing in the given says this is congruent to this. So I have to come up with all 3 parts on my own. I look for vertical angles in the reflexive property. I see verticals, so I'm going to list that next. I'm going to use 3 letters, so it's obvious what part I'm talking about. I'm going to say angle QTP is congruent to angle STR. And I know that because those are vertical angles. Okay, I've got 1 part congruent, it's an angle. Now I get stuck, so I go back to the given to let that lead me to something being congruent. So, oh, this is weird. This means perpendicular. So if 2 segments are perpendicular, they're going to meet at a right angle. So PQ and QS, where those meet, that has to be 90. Where RS and SQS, same thing, where those meet, that has to be 90. Okay, I'm going to be an overachiever here. Proofs, you want to be detailed if you can. So I'm going to say angle Q and angle S are 90. And how did I know that? Perpendicular told me that. So I'm going to say definition perpendicular. I didn't say they were congruent. I just listed that they were 90 because technically I figured that out on my own and I want to be like super extra and detailed. Now I'm going to say angle Q is congruent to angle S, and I know that because they're both 90. All right angles are the same. There's a congruent angle statement. Now, I notice I haven't used this midpoint thing for anything. So that's going to lead me to my 3rd congruent part. They told me that T is the midpoint, or it's right in the middle of PR. So this guy. If T is in the middle, this and this piece have to be the same. So I'm going to say PT is congruent to RT. The reason I knew that was the word midpoint. So I'm going to say definition midpoint. As you can see, I'm abbreviating here. I get lazy. So now I have 3 parts. So I'm done. I want to end with this. I didn't write that from the beginning, but you could have. So I know the triangles are the same. I just have to figure out which shortcut is proving that they're the same. So I look at 1 triangle. I see it's 2 angles and a side. Notice how my markings are like helping me so much. If you didn't mark stuff on the picture, it would be like impossible to say which shortcut it was. I see that it's angle, angle, side. It's not the side in between the 2 angles. I feel like I'm kind of sick because I kind of like this stuff, and I know that so many of you are just going to like hate it. All right, example 3. Real quick here, let's get the given in. You can break it up into 1 statement or more than 1 statement, or you can just list it all with commas as statement 1, reason 1. I know I want to end with this, so go ahead and get that down there if you want. Maybe makes you feel more accomplished. I don't know what shortcut I'm going to use yet, though. Okay, they did mark those angles congruent, so I have 1 congruent angle pair. This is not a congruent statement. This says parallel, so that doesn't count as something being congruent. Just because they're parallel doesn't mean they're congruent. I have to find the congruent stuff. I see the reflexive property. I always look for that right off the bat. Okay, so I know that JG is congruent to JG, reflexive property. The 2 triangles here share it. Now, I'm stuck, and I haven't used this for anything. I haven't used parallel for anything. I'm going to say it a million times. Parallel is trying to show you, just like it was last unit, if you see parallel, you're trying to look for AIAs, SSIs, correspondings. That's what parallel is trying to show you. And guys, 9 times out of 10, it's AIAs in this picture. Okay, check it out. There's your 3-line picture. Lines are parallel, AIAs are congruent. If you can't see them, they're right here. Those guys are AIAs, which would be the same when the lines are parallel. So those are your last congruent parts. You just have to list it, and then you can say the shortcut. So it's going to be angle FGJ, FGJ, and HJG. And the reason, those are AIAs. See if you can figure out the short